Okay, look. First thing, look up here. Put these two problems next to each other in your notebook. This is from page 254. This is the same page you've been working off of in the last few assignments. That assignment I gave you back, I posted that answer sheet. I'll show you that later in class. But those were all the easy ones. That one you just got back, those were all the linear ones. Just go variables up, causes right, you get your answer. I'll show you that later. Put these two next to each other in your notebook. Now, let me see here. 1, 2. I've probably got about three more days of things I have to show you. Your next test will be a test on solving trig equations. I mean, that's what we've been doing since I started this. The assignment you got back, those were linear ones. The assignment you just turned in, those were quadratic ones. We had to get a 0 on one side, factor, set them to 0, get your answers. Obviously, you got to know your special angles. Now, look at these two problems. This is 25 and 28. Now, I'm not going to say anything. I would like to see if somebody's smart enough to maybe come up with an idea of what you would have to do. We're going to start with this one right here. You know what I want to ask you first? How do I want to say this? What's kind of messed up about that? Quentin, right here. Put these next to each other in your notebook. See that equation there? From what I've taught you so far last week, what's kind of messed up about it? It's a weird way of asking a question, but that's the way I'm going to do it. I mean, if I said to you, what are you going to do there? What's kind of messed up about it? I mean, if one of you said to me, well, you know, if you get a 0 on one side, then I'd say to you, well, what are you going to do next? I bet you couldn't answer the question. What do you think? I'm kind of not expecting everybody to know this, but if somebody could come up with this, it would be great.
There isn't really much you can do with that.
Why? No, you're right. With the way it's written, you're right. But why? What's the reason why you can't do much with it? What if this wasn't a cosecant? If it was what, I could probably do it then. What am I talking about?
Have you made it sine?
Yes. If you just have one trig function in your equation, then we could collect terms and go from there, right? Now, guys, these two problems in your notebook, like right up above them, in order to solve them, you're going to have to use identities. Familiar identities that I'm sure you still remember, because it wasn't that long ago. If I said to you, use an identity here so that only one trig function would appear in the equation, what would you say? See, now you should know this. Okay, now remember, no, you guys don't need these iPads right now, so don't have them on. Jack. Isn't cosecant 1 over sine? Right, reciprocals? So in your notebook, go ahead and do that. Now, pay attention here. Do you notice every day last week I kept bringing up freshman algebra, if I've been saying it every day. Now, what don't you like about that equation? It's kind of glaring. You guys never like them anyway. What don't you like about that equation? What's in the equation that you don't particularly care for? I mean, really. There's a fraction in it. So, freshman algebra. What did you always do to wipe fractions out in the equation? Pretty simple what you did. If I said to you, wipe the fraction out in that problem, what would you multiply everything by? This is not a hard question, this part. No. Sine of theta, right? Multiply by sine of theta, multiply by sine of theta, multiply by sine of theta. Now, if you multiply everything by sine of theta, can one of you tell me what to write down? Multiply that by sine of theta, that by sine of theta, that by sine of theta. This part's not hard, what I'm telling you. What would be 2 sine of theta times the sine of theta? Multiply. Howard?
2 sine squared theta
Multiply the negative 1 by sine of theta.
minus sine of theta
Equals,
1.
who has a question? Make sure you're getting this. 'Cause when it comes time for the test, you're going to have 1 or 2 problems where you got to use identities to solve. Now, isn't this what I've already taught you last week? Isn't that a quadratic equation like the homework you just passed in? Somebody, continue. Now you should know what to do. Now you should all know what to do. This is pretty much the homework I just collected from last Thursday. Come on, you guys. You just do this all the time. Come on, this is what you just turned in. How do you solve a quadratic equation? Ethan? You got to get the 0. So the minus 1 comes over, and now you're going to try to, this is not new, fellas, I've already taught this. Now you're going to take your quadratic and what are you going to put down? Rob? Make the 2 parentheses.
2 sine of
So
theta
this will be 2 sine of theta.
plus 1,
All right, go ahead.
plus 1, and minus 1.
Now, everybody look at this. Guys, make sure you're getting this. How do you know that's right? How do you know you factored that right, what he just said? Rob? This is negative 2 sine of theta. This is plus 1 sine of theta. That gives negative 1 sine of theta. And now to finish this, you just, this is what you've been doing. To finish that, you just do what? Set them to 0. So go ahead and finish the problem. This equals 0, or this equals 0. Now it's just variables left, constants right. By now, I think you should be pretty good at this. Divide both sides by 2. So that's negative 1/2. Over here, put the 1 on the other side. So that's 1, and here we go again for the millionth and second time. What quadrant are you in for this? Sine of theta is the negative 1/2. What are the quadrants the answers are in? By now, you guys should have all this part down. How can you really screw up the next test? By not knowing your angles. I've been saying that now for weeks. Ethan?
3 and 4.
3 and 4. What's the reference angle that you need for 1/2 for sine? Donut?
30.
So what's the angle in the third quadrant then? That's 30 degrees away. In the third quadrant, 30 degrees away. 210. And what is it in the fourth? 330. So there's that one. And sine of theta equals 1. That's one of those quadrant angles, right? What's the angle? Sine of what equals a 1? That's that unit circle stuff. It's come up numerous times. Chris?
90.
90. Okay? Look at number 28. And then I'm going to get to the main part of today's class. That's why I sent you that email and said you need your calculator. Ideas? What's messed up about it again? There's 2 different trig functions there, right? What are you going to do? Can't do much of anything right now the way it's written. If you got a 0 on one side, I'd say to you, what are you going to do then? You'd probably say, I can't do anything. It's the one, was I lying? Remember that one identity I said you would keep using and using and using? I wasn't lying when I said it's going to keep coming up, and coming up, right? Can someone tell me what I'm talking about? What's the identity that was used more than any other one? It came up so many times. You just forget so fast. David.
Sine squared plus cosine squared equals 1.
And then the alternates of that were, wasn't sine squared 1 minus cosine squared? Wasn't cosine squared 1 minus sine squared? Are you with me now that you're hearing it again? So what do you suppose you want to do in number 28? You actually would have your choice. What do you think I want you to tell me? There'd be two ways you could proceed. What do you think? And then you would have the same trig function in the problem. Adam?
Move the 1 over?
No, not yet. I want you to do something with one of the trig functions first. You have a choice here. What could I replace cosine squared with? Or what could I replace sine squared with? I don't care which one you do. You want to get the same trig function in the problem. Ethan?
You can replace the left side with sine squared theta plus 1 or the right side with cosine squared theta.
You're not saying that right, Ethan. What could I put in for cosine squared that means the same thing? It's an alternate form. What means the same as cosine squared? The alternate form of that identity. I just said it like 2 minutes ago. Andrew?
Sine squared minus 1.
You said that wrong. You said it backwards. You said that backwards. What's cosine squared equal?
1 minus sine squared.
Everybody, do you understand? Cosine squared is 1 minus sine squared. So put that in. This stuff here, leave it alone. Now, one of you is probably sitting there going, could I have put 1 minus cosine squared right there? The answer is yeah. Noah, you okay?
Yeah.
Now what? See, now you all got, the only thing in the problem is signs now. So what do you suppose you're going to do now? Jack? Why did he say move everything to the right? That's correct. Why? How?
Because you want sine to be positive.
You always want the square to be positive. What about the ones? They're dropping out, aren't they? Aren't the ones on each side dropping out? So isn't this 0 equals 2 sine squared? Divide both sides by 2. I'm just going to flip this around. Sine squared of theta would equal what if you divide both sides by 2? Joe?
Wait.
I'm getting rid of the 2. I'm dividing both sides by 2. 0. 0 divided by 2 is still 0. Take the square root. Take the square root of 0, it's still going to be a 0, isn't it? Okay. Where you at? Quadrant angles. It's unit circle stuff, right? What are the angles? The sine of what angles is a 0? This is just going around the horn again on the unit circle. Chris? 0 degrees, 1 comma 0. 180 degrees, negative 1 comma 0. Now, 2 of your problems for homework are going to be very similar to these 2. Okay, now, here's, please, I'm going to take this slow. This is number 35. Now, have your calculators there. Watch what's going to happen here. Write this down. Please pay attention here, because this is where people are going to get all screwed up if you don't. Now, somebody, what do you think you're going to do with that right now? Before I even say anything to you. What do you think you're going to do with that right now? You already got a 0 on one side. So what would you attempt to do first? Let me ask it to you that way. Isn't that just like the homework you just turned in? Isn't it just like this I just did? What would you try to do with that quadratic? How?
Use the parentheses?
Can you?
No, I don't think so.
I'm asking you. Will factoring work on that? It will not. Now, pay attention. This is why I showed you that quadratic formula last week. And you did them problems that looked like you buzzed right through them real good. I got all your papers back there. Now, the quadratic formula, let me just write this up here again, said this. Now, let's pretend that instead of where it says sine squared of theta and sine of theta, it said this. Just look at what's there. If that was an algebra problem, it would look like that. And you would have said x, pay attention, you would have said x equals, and you would have plugged into there. I'm going to do the quadratic formula here. But this ain't going to say x equals. What's it going to say there? Look at the equation. It's not going to say x equals. It's going to say, please give me your attention here. This one's a little bit more involved. You see, in an algebra problem, you would just have variables there. In a trig problem, you have a trig function there. So if you were doing this, you would say x equals, you would plug into this. What do you think this is going to be on the left? It ain't going to be an x. It's going to be, Andrew, sine of theta. Now follow me here and make sure you're getting this. Sine of theta equals. Now, do you know all these numbers? Dave, get off there. You don't need your iPads right now. Don't you know all these numbers? Isn't that your A? Isn't that your B? And isn't that your C? Okay, now you did this in Friday when I wasn't here. Go ahead in your notebook and plug in your numbers into the quadratic formula. Go ahead. This is the assignment you did in class Friday. That's why I left that for you, because I knew what was coming up today. Go ahead and plug your numbers in. So what would be, Ethan, you have a question?
Oh, no, I thought you wanted us to,
Start telling me what you'd have here, Ethan. Opposite of B.
6,
Plus or minus. Okay, B squared would be what?
36,
Okay, then minus 4 times the A is a 9 times the C is a -1, right? All over what? 18. Now look, this is sine of theta, remember. It's not just x equals. Okay, 6 plus or minus. Now, isn't this going to be 36? Negative times a negative is a plus. What's the number going to be in the radical? Watch your signs. Watch your signs. What's that number going to be when you do all that under the square root bar? Jack? 72. Now, honestly, I don't even care if you reduce that. In fact, don't even reduce it. Now, gentlemen. Now, have your calculator out. This is obviously not going to be a special angle value, is it? Are you kidding me? Look at all that. How many answers are here? Technically, how many answers are there? How many answers are there, technically speaking? Howard? 2. 1 for the plus sign, 1 for the minus sign. Now, look, this is the first example, so get all this written out. 6 plus the square root of 72 over 18. That's one answer. Or sine of theta equals 6 minus the square root of 72 over 18. Now, this is what you got to do right now. Using your calculator, listen to these directions. I want you to get the 4-digit decimal for those two things I circled. Now, do you understand what I'm asking you to do with your calculator? I want you to punch in 6 plus whatever the square root of 72 is, all divided by 18. Joe, what's the matter?
Does it matter if we're in degrees or radians?
Degrees. Yes, this is all degrees, everybody. No, we're in degrees, because remember what I said about the next test? I did you another huge favor. On this test, remember I said the answer could be degrees or radians? I said we're doing all degrees. And I know you like that better, because you're more familiar with degrees than radians. So no, this is all degrees. I would like somebody to punch in 6 plus the square root of 72, whatever that is, divided by 18, and I want you to give me the 4-digit decimal. Round it off. It's going to be point something. Now you all got to do this because you got to make sure all these answers should be identical. Somebody? Got to punch it in your calculator. 6 plus whatever the square root of 72 is, all divided by 18. What's the 4-digit decimal? Your calculator is going to do everything. Just punch it in there. What's the matter? Because you should have it already. You're just hitting the buttons. You got to make sure you're hitting the buttons properly. Jack?
5.8000.
No, that's not right. You're doing something wrong. The 4-digit decimal should be identical for everyone sitting in the room. Your first 2 digits were right. 0.80, Chris.
47.
0.8047. 0.8047. Now, look, because I'm not going to jam this down your throat. Does anyone have a question? Right there. Nick.
How do you get your calculator to go from like, it just says square root of 2.
Nick, I really can't answer that question because everyone has different calculators. I mean, when I'm done here, I can look at your calculator. But you know how before, remember we used to calculate, everybody has different sequence of hitting the buttons, right? I mean, you could just enter 72, hit the square root key, add 6, hit the equals key, and then divide by 18. Everybody should have that number. Is there anyone else that did not have that number? It's got to be exact. Okay, now do the same thing over there, but now it's 6, subtract that. The other one was for the minus sign. So go ahead and do that for the second one. And give me to the 4 decimal places. Boys, this is really important. Does someone have a question what I'm telling you to do? Okay, what is it, somebody? Joe.
Negative 0.1381 if you round up.
Okay, well, anything that's 5 or higher goes up. That's why everyone should have identical. Say that again, Joe.
Negative 0.1381.
You know, look what's on the board here. I'm only going to give you 3 homework problems tonight, like this, where you got to use quadratic formula. Now, that first one right there. Have your calculator there ready to go. What quadrants are your answers going to be? Right there. What quadrants? You always got to know the quadrants. You've done this before. Rob.
1 and 2.
Okay, so right here next to I'm going to go 1 and 2. You got to know the quadrants. What quadrants will the second one be in? Look what it says. It's negative. What quadrants? Noah. 3 and 4. Okay. Do you remember how to find the angle? So let me just refresh your memory. This is where you got to use that inverse sine key, or if it was cosine, inverse cosine key, or if it was tangent, inverse cosine key, or tangent key. Now, if you guys that have regular calculators, you would enter 0.8047 and then go second function key, inverse sine, and it'll give you the angle. You guys that have the fancier calculators, I think you got to go the inverse sine of, and then you put that decimal in. So what I would like somebody to tell me is, what's the angle in the first quadrant for that? Your calculator should be giving it to you. You round it to the nearest tenth. That's good enough. Now, fellas, I'm taking this slow because every single person sitting in here has to be getting the same numbers. What's the angle? The inverse sine of 0.8047. What does your calculator say? Everyone's calculator should have the same angle. Alex. 53.6. Look, 53.6 degrees. Does somebody have a question? Fellas, everybody in the room should be getting 53.6, not 53.8, not 53.5, 53.6. Yes.
Is there going to be questions that ask for minutes also?
No. It's just going to be an angle to the nearest tenth. Let me keep this real simple. No, don't worry about that. Won't come up. Okay, now, you see what I did over here as a refresher for you? Remember, in the first angle, that's the reference angle. In the second, it's 180 minus the reference angle. In the third, it's 180 plus the reference angle. In the fourth, it's 360 minus the reference angle. If it's 53.6 degrees in quadrant 1, how are you going to tell me, how are you going to get the angle in quadrant 2? All you're going to do is, what? That's why I wrote this up here. I'll be damned. You guys forget stuff too fast. If it's 53 here. If it was 30 degrees in the first, what is it in the second? Let's keep this simple first. If it was 30 degrees in the first, what's the angle in the second, Ethan?
150.
And how'd you find that? 180 subtract the 30. So how are you going to give me the angle in quadrant 2? You're going to punch in your calculator 180 degrees subtract 53.6. Go ahead, do it. What's the angle? That's the angle in quadrant 2. What is it? Andrew? 126.4. Who has a question? I'm taking this really slow. Okay, now look over here. And you see this negative sign? You're not going to enter the negative in your calculator. What did the negative sign tell you? Third and fourth, right? So before you can give me the answer in the third and the fourth, you need to get the reference angle, which your calculator will give you. So fellas, enter inverse sine 0.1381. Don't put in negative. Enter in your calculator. 0.1381 inverse sine. Just round it to the nearest tenth. What's it say? What's it say? Inverse sine of 0.1381. Jack.
Or 7.9.
7.9. Now, is 7.9 your answer? No. But look what I'm going to just put that over here. 7.9 degrees, that's the reference angle your calculator just gave you. So, how do you find the angle when it's in the third? How do you find the angle when it's in the fourth? Those are your two answers. There's how you get it in the third. There's how you get it in the fourth. So how are you going to get the angle in the third? You're just going to take 180 and tack that reference angle on. So what's the angle in the third quadrant? Noah?
187.9.
Whoa. No, that's impossible. What did you just say?
187.9.
Oh, I'm sorry. No, you're okay. 187.9. I thought you said something else. 187.9. It's the 180, tack on this little reference angle. How do you get the answer when it's in the fourth? You take 360 and just subtract the little reference angle. So just punch it in your calculator. What's 360 subtract 7.9? Rob? 352.1. Now look, because you might think I'm getting very picky here, which I'm not. When you do this kind of a problem, look at those angles. They're the farthest thing from being special angles. Because when you use a quadratic formula, you ain't going to get radical 2 over 2 or, those special angle values. They're decimals. They're ugly decimals. That's why I said you need a calculator today. Now, take your iPad out right now. Take your iPad out. Go to your textbook. Take out a good sheet of paper. I'm only giving you 5 problems for homework. Now, let me explain this. Go to page 254. I hope you were listening here. Go to page 254. Everyone go to page 254. Oh, I guess I did that one. Everybody get there. Take out a good piece of paper. Look at number 27. Just look at number 27. Were you listening to how I started class? What do you think you would do in number 27? Look at it. It's the first thing I showed you today. And then you can look at 34. What are you going to have to do in 27 and 34? Look at them. It's the first two things I did today. They're right in your notebook. It was the first two examples I did. Joe, identities. So in number 27, you see where that cotan of theta is? What are you going to put in for it? What are you going to put in for the cotan in 27? So that you have the same trig function. Adam. 1 over 10, and then wipe the fraction out, and then go from there. It'll come right out for you. In 34, how are you going to start? Look at it. How are you going to start in 34? Someone? Come on, I showed you this. How are you going to start in 34? Yoo-hoo! Jack.
You put, or you take cosine squared and then make it 1 minus sine squared.
Put 1 minus sine squared in for cosine squared. So for these two, you gotta use identity. Now, as soon as I get out of the way here in a minute, you can write this down. And then 36, 37, and 40. Is quadratic formula. So I'm more